Okay, guys, today's topic is differential equations. Before we start solving these differential equations, we need to know that what are these differential equations. You people are basically familiar with these differential equations. If you recall your P1 work, where you were given dy by dx, that was equal to 2x plus 3. And then you were given a point, like there is a point 2 comma 5, and then you had to find the equation of the curve. So now this equation dy by dx, that is equal to 2x plus 3, this is a differential equation. Any equation which has a dy by dx or any kind of the differential notation in it, that is called a differential equation. Okay, there are degrees of these differential equations. Like this is a differential equation of degree 1. And if there is the d2y by dx square, so that would be of the second degree. Okay, our syllabus mostly deals with the first degree differential equations. Acha, you people know that how to solve this equation, because that in your P1 you have done that. Like, you know, you keep this dy on one side and you move the dx to the other side. Okay, so now this one side has to have the dx on one side, the other side should have dy. Okay, now this would mean that the left hand side would be integrated with respect to y, and the right hand side will be integrated with respect to x. So that is the main step of this differential equations. When you start at solution, you have to split your equation in a way that one of the sides has to be integrated with respect to one of the variables and the other with the other variable. Okay, so the rest is, you people know how to differentiate, integrate this. This is going to become y, and this is going to be x squared plus 3x plus c. If you leave this up to this, this is called the general solution of a differential equation. Okay, and if you put the given values of y and x here, and you determine this value of c, like if we do it like this is 5, that is going to be 4 plus 6 plus c, and your c is minus 5. So if you write it like this, y is equal to x squared plus 3x minus 5. So this one is called the particular solution of the given differential equation. So this is called the particular solution. Okay, so when it says just the general solution, so you just leave it up to this where you find this c. Now there is a question that arises that since we are integrating both the sides, then why are we just writing the plus c on just one of the sides? So the answer to this is that if you look at this equation, an equation can have only one constant. And when you differentiate it, when you find your dy by dx, that constant is eliminated. Okay, and when you integrate it to get that equation back, so obviously we'll have to write that constant once here, which is plus c. Now this is
Sir,
up.
isn't it 3x on the particular solution? X squared plus 3x.
Oh yeah, this is, I'm sorry, this is yeah, thank you, Beta. This is 3x. Okay, now you can write this c if you want to the left hand side or to the right hand side, but you have to write this just once. Okay, now this was a very easier kind of a differential equation over here. Okay, now this will become a bit more and more complicated when you move to the the other the extended versions of this. For example, if I take you to the exercise 10a, let me write some questions here. Okay, guys, now I have written down some questions here, and I have to focus on that first main step of solving the differential equation, where we, like in this case, one of the sides will have dy, the other side will have the dx. Okay, Now, when we do this, we really hate these plus minus signs between the terms, okay? So I would rather treat this as one term over here. This is x cubed minus 6. Because if I just move this 6 to the other side, see what will I be getting? I will be getting 6 plus dy by dx, that is equal to x cubed. Now, I am going to move towards a disaster because I cannot solve this equation. If I do that cross multiplication, you see that, the things are not going to work here. So if I take this as one term over here, I keep dy on one side and I let this be on this side. This is x cubed minus 6. Now this is quite clear to me that I have to integrate this. I'll get y, and I should know how to integrate this. This is x is for 4 over 4 minus 6x and then plus c. Okay. Similarly, if you look at this f part, again, we do not like this plus sign over here. We hate this sign, this plus sign, okay? So I'll be moving this x to this side, okay, first of all. So this will become secant x sine y dy by dx, and that is equal to 1 minus x. Now, I'll consider this 1 minus x as one thing, one term, okay? So now this left-hand side can have sine y over here. So this is your sine y and dy. Okay, the secant x is basically 1 over cos x. If I just change that with 1 over cos x, then I can easily say that this is going to be 1 minus x into cos x, and here I have that dx. And then we can integrate both the sides. Now this side has clearly all the terms in y. This has all the terms in x. Okay, now you must be really good at integration, because up to this was a new thing for you, where you were splitting the equation into two parts, one with the y terms, one with the x terms. Now we know that the integral of sine y is minus cos y, okay, but we should also know how to integrate this. Who will tell me how to integrate this 1 minus x into cos x? Yes, any idea, bacho? How can
Sir,
I?
by part.
This will be integrated by parts. I'm just going to write that formula here, and then you will do it yourself. This is going to be uv minus u dash v. So this is your u that can you differentiate and get rid of, and this is going to be your v dash. Okay. If I take you to the next page, um, yeah, these are simple cases. Yeah, if you look at this 10th question, again, we don't like this plus 2y. So this plus 2y has to be moved to the other side. This is x cubed dy by dx, and that is 1 minus 2y. Okay, now this is going to be dy on this side and dx on this side. Okay, so when you keep dy on this side and keeping this as one thing over here, okay, as one block, so this is going to come over here as a denominator. This is dy over 1 minus 2y, and then you move that to this dx goes to this side, and then this is going to be dx over x cubed. Okay, so I can write it as 1 over 1 minus 2y dy, and that is going to be equal to 1 over x cubed dx. Now again, your skills in integration, they are going to be tested. So how would you integrate this 1 over 1 minus 2y? You will have to be quick,
Sir, and then true.
because we can't shift this to the numerator, okay? So I'll be writing a minus 2 over here, and I'll be writing a minus 1 over 2 over here. And this can be written as x to the power minus 3, and then you can integrate it, okay? I'm just going to leave this. Now, this is a very interesting question. I was telling to my students that once we had a competition between two groups of different teachers, and then there was a tie, and the other teacher told me to give a question so that the tie is broken. Then I just took out this question from an old book. And do you know what happened? one of the groups, they were able to solve this, but the same year, this kind of a question was there in the examinations. So that was for the first time we had a question like this. Okay, so the students were asking that if I knew that what is going to be, what was the paper about. So you see, to solve this using the properties of the exponential properties, I can split it like this: e raised to power x over e raised to power y, and then it becomes e raised to power y dy, and this is e raised to power x dx. So guys, the first main step is to think about and to be tactful in splitting the equation in two parts, where one has the variable y, maybe the other has a variable x. Like if you look at this case here, this is dA by dr. So I'll just keep dA over here, and this will be 2 pi r dr. This is dA, and this is 2 pi r dr. Now, sometimes students, they try to move this to the other side. There's no need to move this because this is just a constant, okay? So this would be A, that is going to be pi r squared plus c, okay? Now this one here, this can be written as dv over v, and that is simply 2 dt. Let this 2 be here, okay? And then you can integrate. So that was the first part of the solution of the differential equations, where you split your equation into two parts so that you can integrate one of the sides with respect to one variable and the other side with respect to the other variable, okay?